All right, today's homework crisis problem comes from actually one of my former students. I actually lovingly call her my non-biological daughter. She is the one, shout out to her for gifting me this happiness is being a granny shirt. All right, so these homework questions are about even and odd numbers. Now, I will say I made up some similar questions because in case you're using the same book she is, I want you to be able to have a chance to have your students practice with a different problem. Okay, so this was the first one. How can the base 10 blocks show that a number is even or odd? Write an equation and explain. Now, back in the day, the way that we learned even and odd numbers, as we said, an even number ends with 0, 2, 4, 6, and 8. An odd number ends with 1, 3, 5, 7, and 9, right? Well, that is how you identify even and odd numbers, or a way that you can identify them, but it's not the definition of an even and an odd number. The definition of an even number can be decomposed or split apart into two equal groups. An odd number cannot be decomposed into two equal groups. That is all that we're looking at with the definition. So if we're looking at this 485, we see it's close to two equal groups, but they're not. So we can show in the equation, we can show 485 is equal to 243 plus 242. But no cigar. We cannot decompose those into two equal groups. And so if they're asking to explain, we're just wanting them to say, well, it is odd because 485 cannot be decomposed into two equal groups. Now, how about 66? Well, 66, they've got this decomposed into 33 and 33, two equal groups. So we could write the equation 66 is equal to 33 plus 33, and we can say this is even because 66 can be decomposed into two equal groups. All right, the next question she had, it was a true false question that is very similar to this one. All digits in an even number must be even. False. We are only concerned about the ones digit. So this would be false because we only look at the ones digit. Now, why is that? I always like to talk about why. Why do we just look at the ones digit? Well, let's think about a number like 372. Okay. 3 and 7 are odd numbers. Okay. But what is their place value? 7 is in the tens place. That's 70. Can I split 70 into two equal groups? Absolutely. 35 and 35. 3 is in the hundreds place, so that's 300. Can I split it into two equal groups? Absolutely. 150, 150. So we are only looking at the ones digit because the ones digit is what tells us whether or not this number can be split into two equal groups. If I wanted to rewrite this as a true statement, I would just simply say the digit in the ones place in an even number must be even. All right, here's a little shout out question to Lawson. Lawson has a collection of an even number of Legos. He wants to display them on two shelves. Which of the following arrangements are possible if he puts an even number of Legos on the shelves? Okay, so he's got an even number of Legos that he's going to put on both shelves. Could he put an even number on each shelf? Absolutely. What if he had 120 Legos? He would put 60 on one shelf and 60 on another. And it doesn't even have to say it has to be the same number, but I like talking about that since that's the definition of an even number. But it could be 40 and 80. So yes, this is possible. Now, could he put an odd number on one shelf and an even number on another one? No, because the definition of an even number is that it can be divided into two equal numbers. There's no way we can divide it into, decompose it, I'm sorry, not divide, decompose it into an odd number and an even number. Now this one might be the one that's a little bit tricky. If he's got an even number of Legos, could he have an odd number on each shelf? Yes, because definition of an even number, it can be decomposed into two equal numbers. So what if he had, let's look at this one. What if he had 66 Legos? If he had 66 Legos, he could put 33 on one shelf and 33 on another shelf. So an even number can be decomposed into two even numbers, or it can be decomposed into two odd numbers. What it cannot be decomposed into is an odd number and an even number. Now, if you wanted to change the problem up and say he had an odd number of Legos, if you've got an odd number, the only possibility is to have an odd number on one shelf and an even number on the other. All right, hope that helps. Thanks for joining. Oh, by the way, if you want more in-depth support with even and odd numbers, just go check out the other videos on Math with Granny, the student version there. We'll go a lot more in depth.